In our last lecture, we have discussed about the force between the two charged particles. Here, we are going to talk about if there are not only two charges but a system where number of interacting charges are there. Then the force between them is given by the superposition principle. Here we are talking about how much is the force lying between the multiple charges. In a system, we are having a number of interacting charges. The net force on any charge is equal to the sum of the charges exerted on it by other charges. To understand this superposition principle, which states that in the number of interacting charges, we have considered one charge and we want to find out how that charge is getting the force because of the rest of the charges. So, for that, we have taken a figure in which Q0, Q1, Q2, Q3, so on, Qn are the n number of the charges. And we want to find out the force on Q0 because of these charges. So, this is what is there. Suppose there are n number of point charges, that is Q0, Q1, Q2 up to Qn. Then according to the superposition principle that I have stated earlier, the force on say charge Q0, we have considered Q0 as the point charge where we are going to find out the total force because of these charges. Then, according to the superposition principle, let F be the force experienced by Q 0 because of these charges will be given by the sum of the forces by which F naught 1, the force between Q naught and Q1, F naught 2, the force experienced by Q naught due to charge Q2, F naught 3, the force experienced by Q naught due to Q3, and F naught n is the force experienced by Q naught due to charge Qn. So adding all these forces individually, we will get the total force exerted on charge Q0 by these charges Q1 to Qn. So this is what the superposition principle is. Now, there is one more important conclusion. The force exerted by one charge on the other is not affected by the other charges. If this is a very common conceptual problem that comes on this conclusion, that if suppose F is the force between the two charges, how that will be getting affected if another charge, say Q through, is present over there, then we will say there won't be any change because it is what the force exerted by on any of the two charges will not be affected by the presence of any other charge. This, according to the superposition principle, the total forces of F experienced by Q naught is given by the addition of F naught 1 plus F naught 2, F naught 3 up to F naught n, where these are the forces individually between Q0 and Q1, Q0 and Q2, and so on. Now, to find out the value of F01, it is the force between the 2 point charges Q0 and Q1. We will apply the Coulomb's law. According to that, this force will be given by 1 by 4 pi epsilon naught Q1 Q0 divided by R1 square. Similarly, we can find out for the individual two charges on applying the Coulomb's law and adding all of them to get the superposition principle. We can take out 1 by 4 pi epsilon naught common, and then we'll get the total force experienced by Q0 is given by the equation.